problem and the proposed model, and we end with a quick preliminary results, screenshots of the platform, what we have achieved. Over to you.
So as my co-presenter mentioned, licensed data assets are underutilized. Libraries invest significant amounts in acquiring unique data sets, things like 19th century newspaper, historical census records, and scientific databases. But when we looked closely, we realized many of these valuable data sets are barely used because researchers runs into barriers like unclear data structure, technical complexity, and lack of programming experience. So from our experience supporting data related projects in the library, we noticed that the gap isn't about availability of the data, but it is about accessibility and the usability of the data. Next slide, please. So what exactly the researcher want? So if you look at the current state, most of these data sets comes as a large and raw files. They require significant technical expertise. A researcher without specific programming or database skills has to depend on someone else, so which slows down the entire process and often discourages them for using the data at all. So, what exactly they need, like what characters they want, is like easy discovery and exploration, the ability to quickly find data sets relevant to their work without spending hours figuring out where exactly the data set live. And they need clean, documented, and reproducible data sets. So, well labeled data sets with clear metadata and context, so users can really trust and understand the information. No code or low code access. Not everyone is familiar with the SQL or other programming language. So tools that allow point and click exploration makes a huge difference. And immediate analytical capabilities. Ideally, researcher want to able to visualize or filter the data right away, not spends week cleaning or transforming it, and they wanted to share the visuals with others. So next slide, please. So this slide shows how our approach changes the researcher experience before and after using the proposed model, like our curation model. So before I start, I will explain what exactly our curation model is. So it is the process for taking the raw data and turning the data into a clean, organized, and usable form for researcher. So, before the curation model, the researcher had to do everything in the hard way. They start by downloading huge files and then spend weeks just trying to understand how the data was formatted and structured. Even after they find the data, they need to write some complex queries to retrieve the data or to retrieve some parts of the data. At this point, many researchers simply give up because it takes too much efforts and time. So, after using the proposed model, a researcher can simply search for the data set, something like labor stats Nashville 1994 to 2002, and they can quickly preview the data set right away. And they can then access a clean filtered version and start their analysis right away. No complicated setup, no weeks of cleaning or scripting. Next slide.
So here for to solve this problem, the platform that we have used is Databricks. Databricks provides a unified platform to handle the entire data lifecycle. The key advantages of this platform are it's a cloud-based lakehouse architecture, and it has a pay-as-you-go model for the computation power that you use, and it can handle large-scale workloads. We are talking about petabytes of data for for a single project, and also like a billion rows of data it can handle it. We're not saying that we'll stage all those data sets. We're just saying that it is possible to do that kind of research with this platform. And also there's not much upfront investment to just start the research. So if you're thinking of dealing with petabytes of data, then you can't and usually what people do is they provision a $15,000 system, and then they start the research. Instead of that, you can uh, test some part of data sets using the compute. You can create the compute on demand. And all these $15,000 systems, they get outdated in a year or two. But when you use a cloud platform like this, you will have the most updated hardware that's possible for. And this is kind of useful when you're doing analysis like so even if you have a $15,000 computer, you are not going to use it for 24 hours all day for the whole year. You might only use the compute power for like 2 hours each day. This is the best use case for that kind of scenarios. And in this platform, we can be used to transform the raw data sets into accessible data products that researchers can actually use.
So far we have talked about making data easier to access, but another big part of this project is making data easier to discover. And that's where AI enhanced metadata comes in. So before I dive in, I will give you more information about the metadata. It is metadata means data about data. It provide information about what a data set contains so people can understand and find it easily. So usually writing or updating metadata takes a lot of manual efforts, right? So we use native Databricks AI feature for metadata extraction, tagging, and description generation, which makes dataset easier to discover and understand. Next slide.
So, in the whole curation model, we break it down into three phases. This is the first phase: strategize and stage with human in the loop. Uh, in this phase, we use this phase, the human expertise is crucial in making the automation decisions and the strategic decisions, like what data to keep, what column to have, and what columns to drop. Or so exactly, it's easier for me to explain it with an example. Say there are 19th century newspapers, and you want to stage them so that research can use. So they come in form of hardwares. Usually, what happens is you put them in a cloud bucket and wait for the researchers to ask for access. The problem with that is, first, it's based of cloud computing cost because most of the research can't view it. And what I mean to say with the strategic decisions is that so when the images of the newspaper transcribed, say the transcription quality could be very bad because the data sets might be acquired like 10 years ago. Very bad in the sense, what I mean to say is compare it to current transcription quality. So it's better to store only the images and organize the images and drop the text column to save some storage space and save on. So the here the data engineer works with in this step the data engineer works with the subject matter experts to understand the research needs, and the critical decisions about the staging approach are based on the expected usage patterns of the researcher. and and this step creates a foundation for all the subsequent automation that's going to follow in the next steps. And also here the subject matter expert would be probably, if it's a business data set, it would be a business librarian or a professor who wants to access the data set. Next one. Yeah.
So next stage is profile, clean, and refine. This phase is all about improving the quality of the data. We start with profiling and validation, where we carefully look at the data structure and contents. We check for the missing values or any inconsistencies in the data. And we work closely with the subject matter expert to make sure the data actually makes sense. Next, we clean and standardize the data. This includes fixing errors, handling missing values, and applying quick quality checks so the data is consistent and reliable. Finally, we enrich and finalize it by adding some calculated fields if required, and connecting it with other data sources if needed, and optimizing it for researcher use. So by the end of this phase, we move from messy raw data to a clean, structured, and research-ready data set that can be shared confidently. Next slide, please.
So yeah, this is my favorite phase. This is the third phase, the package and deploy phase. So in the first part of this phase, what we do is add the metadata and the documentation that's required for the goal tables that are a result of the previous step, and create sample notebooks. Sample notebooks in the sense you take the data set and probably add some sort of analysis where they can, it's like even it could be very simple, like mean median mode if it's a finance data or something like that, so that people can explore the data sets by using that sample notebook. Um, and this phase, the focus on the discoverability and the usability, that's what we do with metadata and usability in the sense you talk about having sample notebooks or any other byproducts. And also in the second part, so from raw data sets, we created data assets. And from that, we need to transform it into data product. That's where it's a little bit tricky part, where you stage them in the marketplace. To stage them in the marketplace, not you need to have the table, the raw clean data set, and sample notebooks where they can the researcher can explore the data set without actually downloading the huge data set. And also the third one, which makes it actual data product, is having an SLO. So I want to spend a little bit more time on that one. So SLOs are service level objectives. So so most of our data sets that we are currently dealing with are stuck at this day SLO phase. I work for TV News Archive. We are almost in a process of doing this and making this happen over here. But the service level objective is tricky because you need to guarantee a researcher something like uptime, fresh accuracy. If you don't do that, and it just raw data stored in a different format. So the whole abstraction layer that we have, like placing the data set in the marketplace, is not of much value. And also versioning is also present in part of this SLO. Say if a researcher ran analysis with a version 1 and then the data set has gone to version 2, the version 1 will always be available here, so that if they want to run the analysis back on that specific data, that version of the data set, it's still possible. And this data versioning is by default is a native feature of the Delta tables, which is a part of Databricks. Delta table is created by Databricks, but Databricks in itself is a proprietary platform. But the Delta table, Delta format is a open format. So you can actually share that tables with anybody, just like you share a CSV. And here is you know, summed up stakeholder involvement. You have data engineer, subject matter expert, data analyst, and a catalog librarian. So most of the heavy lifting of getting the data into the platform is done by data analyst. The quality checks are done by the data analyst. Sometimes if it's a smaller place, both data engineer and data analyst are the same person. And the and how to clean, like what to hold and what not to hold, is decided by a subject matter expert. And the documentation for the staging the data assets in the Databricks marketplace is done by a catalog librarian. And I just want to show you some screenshots of how the whole thing looks. This is how data products look in Databricks marketplace. And this is how a product offering looks. So we are displaying a public data set. So here it's federal rate. We created this whole data product over there because it's easier to do that and show it. You can see all of this description is added by us, and the sources are mentioned. In this screenshot, it's not visible, but just beneath this screenshot, we have uh, the sample notebooks which they can run. And here are the access patterns that you can see. So if you want some, not all data can be shared with everybody. So if you want, if the data can be shared publicly, then you can use the public marketplace. But if you want to limit with your organization, you can limit it with the private exchange. But the experience is pretty much more than the one and the same. What makes the data assets data products is having these assets all together. So you can add tables, files, the AI models or ML models, and the runnable notebooks. That makes it as a whole data product. And this is how the delta table looks. And you can actually, the interface of Databricks is very nice, that you can actually query basic stuff here. It will give you the exact query that resulted in that output also. And you can see a subset of the entire result. You have a like 100 billion rows, but you still want to see the structure. You can do that here, and it happens in few seconds only. And the versioning, so the way delta table is designed is that whenever you update a new data into the delta table, that is stored as a different version of the whole data set. So that's where you can do the versioning. And if you want to get rid of those versions, you can do a basic command and get rid of those versions. But for library data sets or licensed data sets, I think this is a really good uh, data format to use. And here's how the notebooks look like. You can use Python, SQL, and R in this. I think Sathvika will add more to this one.
Yeah. So ready to run notebooks are my favorite feature because it provides immediate hands-on experience for learning and analysis. As Vaibhav mentioned, they support multiple programming languages like Python, SQL, R, and Scala. But Python and SQL also have serverless options, so user can run code instantly without setting up any infrastructure.
So you can if the whole platform and the model and everything, you can submit like a farm to table model, wherein you take the raw data sets, you clean them up, you stage them, you do all the things, and then you make it like a total product. Maybe you create the researchers might create an application, like an app or something over the top of that, that can also be stored in the same marketplace and probably licensed or sold or like reused.
Yes, to wrap up, implementation doesn't require a large upfront investment. So start with one high value underutilized data set and partner with the researcher to ensure you are addressing a real world problem. And you can use Databricks free edition for the initial pilot. Finally, measure the usage before and after curation to demonstrate the impact. I know we are running out of time. And
Oh, special thanks to Jim Duran from the director of TV News Archive and Meggie Center, because they are the ones who are funding the whole Databricks platform here. Thanks for the Meggie Foundation.
Thank you everyone for attending the session, and special thanks to the planning committee and the organizers.
Thank you all so much. I am going to move on to the next presentation, but if you want to look at the chat and answer questions there or in the notes, that would be fantastic. Thank you.
Nice.
All right, so
I am looking at the questions.
yeah, can we go ahead and if you want to just answer them there, I'm just going to move on to the other next presentation since
sure.
Awesome. Thank you. All right.
Can you all see my screen?
We can now, yes.
Perfect. Okay, let me. Sorry. Give me one quick second. All right, there we go. Trying to turn my video on too. Can you see me now?
You're all good.
All right, wonderful. Thank you so much. Well, hi, I'm Nicole Stevens. I am one of the science and engineering librarians here at Vanderbilt University, and we've got Josh here with us today too. I'm going to hand it over to him for his introduction real quick.
Hello, I'm Joshua Borycz. I've been a science and engineering librarian at Vanderbilt for about 6 years now. And today we're going to be talking about integrating AI into research data management courses for biomedical engineering students. Back to you, Nicole.
Thank you. All right, so before we get started into anything, we just wanted to let everyone know that we dotted our I's and crossed our T's, and we are good to go regarding any conflict of interest disclosures, and we've gone through the appropriate avenues for IRB as well. And some institutional background with Vanderbilt. So Vanderbilt has about 13,000 students, and that's across all boards, so undergraduate, graduate, and professional programs. Vanderbilt School of Engineering has roughly 1,500 undergraduate students, and the Biomedical Engineering program offers or gives out about 350 to 400 undergraduate degrees annually. So it's a pretty big program within the School of Engineering and Vanderbilt itself. So just some background on our partnership with the Biomedical Engineering Department. We've been integrated into a few different classes. So the 2900 class is where we started, and then 3900, 4901, which is what we're going to talk about today, and then 4950, which is the senior design. So as you can tell, we've been through this class and with the students to kind of evolve with them as their information needs evolve. So for 4901, the focus was going to be more on understanding research data management and applying research data management fundamentals to their coursework and hopefully their everyday life in the future. So some of the limitations of the previous data literacy instruction program, which was for the 4901 class, as I previously mentioned, was that the instructional interventions in research data management were didactic heavy. The students introduced to effective research data management practices it was done through a didactic lecture. The hands-on exercises were limited to diagnosing problems with messy data sets, and there wasn't enough time in the class period to gain experience cleaning the data themselves. So AI tools have become part of our teaching workflows and toolkits. So here's a paper that Alex and Josh had written talking about integrating LLMs and Gen AI into information literacy instruction. And we talk about the 5 I's, which is something we go over in every course we're in. And sometimes we'll even demonstrate using Gen AI and asking a question. So we talk about how it's incomplete, it can't access most recently published work, it's inconsistent, it's unable to replicate the same results for the same question over time because it's based on statistics. It's incoherent, so it can't provide its sources for where it got the information. It can't always tell you. It's illogical, so it doesn't always solve problems, and it's indulgent, which I like to say is great when you're having a bad day, but maybe not great when you're doing your research. So our research questions were, can data literacy instruction that highlights the use of Gen AI tools with research data management improve undergraduate students' ability to design machine-readable tabular data sets, preserve data from catastrophic loss, organize data using best practices from information science, and integrate Gen AI applications into their workflows? So the start of the intervention was data hygiene. We talk about how you want to have a central cloud-based location for file storage. You want to make sure that what you're doing, people in your group all have access to it, not just one person. We talk about README files and the importance of README files and what they can contain, how they can streamline onboarding, especially if you have a whole lot of people coming in and out of projects. And we talk about project-centered folder hierarchies. So making sure that you have everything, if you have a project, you have things broken up, or you have an organization system that makes sense to not just you, but the people you work with. You have meaningful, readable file names. You want it to make sense so people can find it, and tidy data. So the overview of an intervention, we talk about project organization. I'm sure that everyone has buckets of Legos that look very much like the one on the left. I have to say I'm guilty of it too sometimes. There's type level organization, which is in the middle, and it's clean, it's nice, but if you want to have a project, you're obviously going to want to go with the level of organization that's provided in the box set of Legos. It's got the instructions, it's got everything bagged where it needs to be, you know where your steps are, and you know how to get there. So we did 3 demonstrations with AI, crafting a data management plan, designing file hierarchies and file naming conventions, and creating README files. So we're going to talk specifically about using AI to create a README file, which we asked AI to do, and it provided us a template like what you see over here. So this is a demo that Josh did, and we'll walk through this as well after. This is a quick video. So you can see that we gave it the template, we put paper in there, and we asked it to fill out the information, which, as you saw through the demo, it did. And here's a better look of that. We used the paper that you saw at the previous example where we asked for the template. The paper was in the background, and it filled out the information that it could, and what it didn't, it left blank, but it was still easy to find. All things considered, this is a pretty good starting point.
Okay, thank you, Nicole. Now I'm going to take over and describe the methods and results of this paper. So we had a twofold approach to gathering data here. We wanted to make sure that we had some quantitative data and qualitative data to get an idea of where students' confidence was before our instruction and after it. So for the quantitative data, we asked 3 Likert type questions, one on how students manage their research data and how confident they feel about managing it. And then using AI tools for research data management, their confidence level in that. And then finally, their confidence that they could use AI tools ethically for research data management. So these 3 tools you can see on the right. And then we had 4 open response questions that asked students to describe strategies for RDM to make sure that it backs up the quantitative data. So our results for the quantitative data indicate that students here in this plot feel pretty confident about organizing their research data. So that didn't change very much. You can see the p-value in the table on the right in red is not significant. So the students were confident at around 4.2 and only moved up a little bit after our instruction in the post-test. So students feel confident that they can organize their research data. However, our instruction on using AI to organize research and using AI ethically to organize research data indicate that students did not feel confident about that before, and that their confidence increased substantially after our instruction. So you may think, why did students feel so confident before? Is that confidence justified? Well, that's one of the reasons that we asked the qualitative questions. So one of the qualitative results is, based on the question, what is a strategy you can use for creating spreadsheets that are well suited for data analysis? The pretest responses were based on utilization of functions and formulas. Basically, students just say, we're going to use Excel to organize spreadsheets and also use pivot tables. So it's focused on a specific tool, Excel and pivot tables, which is not a very sophisticated analysis. It's not talking about principles of research data management at all. But after our instruction, students focused on, in the post-test responses, data tidiness, and structure. In a specific example, one student said, keep variables in columns, values in rows, and keep 1 response per row. This is exactly correct. And then consistent organization and naming conventions. It is important to name files consistently and not just have a random subset of numbers printed out based on whatever the file is that you've saved from what program. So these post-test responses are substantially better. And this indicates that the student's confidence was slightly misplaced beforehand. All right. In another example, what is one way you could use a generative AI application to manage or process research data? Data analysis and pattern recognition, ask it to suggest analysis that can be performed. Summarization of research results. One student said use generative AI to summarize research papers. So these, again, not great responses. Essentially using AI to summarize things and asking it to suggest analyses. Neither of these things really have to do with research data management. But the post-test responses focus on actual research data management, data cleaning, and tidy data creation. You can have it tidy your data or come up with good organization schemas. Data processing, consistent organization, and naming conventions. Copy and paste data into AI and provide instructions on how you want it to process that data. So these actual responses focus on how research data management could be improved and made easier with AI. All right. So just to drive this point home, our first interpretation is no significant difference pre-post confidence inability to organize data was the result of a disconnect between the confidence of the students and their actual research data management knowledge. Okay, and this was revealed in the open responses. Students were just saying before, we're just going to use Excel to organize our data, which isn't really a good response. You need to understand the principles of data organization. Then the second one, significant differences in the pre-post testing confidence for using AI for research data management and ethical AI use in research data management. So their responses improve substantially. They're far more sophisticated and detailed in their post-test responses. They're focusing on principles. They're focusing on things that actually matter to research data management and can be generally applied, and not just using Excel or creating pivot tables or having AI summarize papers for you, which don't really have anything to do with research data management. Okay. So what we plan to do next in our research after getting these promising results is to continue to collect data from students enrolled in the spring sections of BME 4901 to see if we can get this consistently, perhaps even expand the repertoire of instruction that we're doing and make more complicated introductions of how AI can be used for research data management. And then we want to invite students who completed BME 4901, these seniors, in the spring to complete an additional exit survey to make sure that they're actually applying these things later on in their research and their further coursework. So this would be something like an exit survey that will ask students to describe their use of generative AI within their coursework broadly, including research data management tasks, because these things should continue on later into life if they're based on principles that can be applied anywhere, rather than just a particular skill in using Excel. All right, so this work is based on some papers that Alex, myself, and Nicole have published together, along with Amanda Lowry, who is the instructor of this biomedical engineering series of courses. So you can feel free to look up some of these publications to get more of the details on this if you'd like. All right, I would like to thank my colleagues, Alex Carroll, Nicole Steffens, Nadia Merritt, for working on this with me and helping us gather this data over this long period of time and do this analysis and write these papers. And you can feel free to contact any of us with questions or details about this research at any time if you like. And now we have a few minutes for questions.
Awesome, thank you. Yeah, there's been a couple in the chat, and those are being answered as you go, just about your internal platform and that you always recommend students to use that tool. We have another question. I wonder if you address data privacy and confidentiality in your course. Using AI to manage data means that they have to release data before publishing or getting patents. Can you comment on that?
Absolutely. I'll go first, and then Nicole, if you want to add something, feel free. So yes, we do encourage students to use Vanderbilt's AI tool. One, because it has a variety of AI, generative AI models within it. So it includes Claude, several instances of Claude, and various instances of ChatGPT as well. Even the newest one, ChatGPT 5, is in there, as well as some added tools like an ability to connect to our teams within Vanderbilt and overlook email, as well as an ability to create assistants that can be used to upload and review papers and data and clean data. And one of the advantages of this is that it is self-contained within Vanderbilt's servers. So it doesn't go to OpenAI to be trained by their language model. It doesn't become owned by them. They don't get to steal it and use it for whatever they want. So the data that they upload there is more safe and contained within the community of Vanderbilt. So in that sense, it is better for students to keep that data safe there. Now, that doesn't necessarily mean it's perfectly safe, since the Vanderbilt community might be able to access it in some way, which I don't necessarily understand. You'd have to ask a computer scientist who works in that particular area to understand that. But it is safer within this particular tool. And so we do talk to them about keeping data to yourself and not necessarily sharing any data publicly that you wouldn't want someone to, take your ideas. Anything to add, Nicole?
I mean, we talk about how different platforms work, so just being aware of that and where to find that information. So if you're going to put something in ChatGPT, like, be aware that what happens in ChatGPT doesn't stay in ChatGPT.
Thank you. One other question, what's the intensity of instruction integration into BME courses? Example, how many sessions per semester?
So we just do one session per semester for each class. So it's based on their lab reports essentially for BME 2901, 3900, and 4901. They're all writing courses, so they're working on writing research along the way. So we teach how to write methods, how to write intro, how to write a discussion at each step of the way, and teach data management as well. So essentially, that is the goal of the course, and we focus on finding resources, writing methods, and things like that throughout.
Okay, one last question. Did you consider the use of in-house LLM servers running open source models instead of enterprise level data protection provided by OpenAI, Google, Anthropic, etc., to ensure privacy and confidentiality?
I'm not sure that I'm equipped to answer that question. I don't think we did consider that. I mean, we just have this tool available from Vanderbilt. It's a good alternative. It has a lot of flexibility and options. It's integrated into the tools that we use every day for work. So that is the option that we went with. And we really want to avoid having to pay or get some OpenAI account if we can ourselves.
Awesome, thank you. We'll move on to the next one. If you guys still have, you can still use the chat or the notes to ask any other questions, but we'll queue up the next presentation.
I'm Matt Jansen. I'm the data analysis librarian at UNC Chapel Hill, and I'm joined by Rolando Rodriguez, who is going to talk to us a little bit later in this project. And we're going to talk to you guys today about some of the work we've been doing exploring ways to improve some of our OCR workflows using, again, the word of the hour, generative AI. So let's go ahead and slide through. Yep, there we are. One more slide. Here we go. So we've had several projects over the past few years where we've needed to extract some sort of structured data from a large quantity of scanned text, images, things like that. And there's usually a pretty wide set of challenges that come along with this. For today, we're going to kind of just to set the stage, talk about a couple different projects that have been significant for us over the last few years. One is the On the Books project. So the On the Books project is started back in 2019 and aimed to parse North Carolina session laws from historical session law documents. And to then identify Jim Crow language within those laws. So this was looking at 1866 to 1967. That project has since expanded to include more laws from Virginia, South Carolina, and we're currently kind of getting a new phase off the ground. Most of the funding for this has come from the Mellon Foundation. the new Mellon-funded phase that is digging into earlier laws from North Carolina, some laws from Texas, archival images, more handwriting, all that kind of stuff. So we're really kind of going into a broader space and a stopping point here where we're thinking a little bit about how we can mix up and improve this process. The other big project that we've worked on is a movie catalog card project. So this has been a collaboration with an English professor here at UNC, Martin Jansen. And these are somewhere around 100,000 scanned cards cataloging films during World War I. These were films that were to be made available to the troops in Europe during the war, and it's kind of early cataloging stuff. It's a very kind of volatile and changing time. Something's being set up on the fly. So there's a lot of variation in what we see in this collection. You can see it in the images here. Sometimes we have forms, sometimes we have all kinds of stuff. A lot of these films no longer exist in any form. So this really is a valuable resource, as often the only remaining evidence that some of these films ever existed. So we're trying to extract from this side some of the key pieces of information, titles of films, publishers of films, the dates they're released, all that kind of stuff. It can be pretty challenging. Slide. So both of these projects come with their own variety of unique challenges. The cards follow a really wide variety of formats. We saw that in the last slide. We see it here too. We've got handwriting, we've got stamps, we have circling things. We have different forms that change over time. We have different people filling out the forms and making different judgments on what goes where. We have some that are just loose handwriting. So there's just a lot of variation there. There's variation in how they're scanned. Sometimes it's several cards scanned together or one card. There's a lot of variation there. The law project had, one of the key challenges we had to deal with the law project was, you can see highlighted in the image above, we had to come up with a manual workflow to isolate and remove marginalia. That is text kind of going off to the right hand of the main body of text in this image is basically old school finding aid to help people find stuff as they were skimming through these session laws. And unfortunately, all this stuff was printed very, very close to the main text. So it would get kind of garbled in with the rest of the OCR results when we tried to OCR it. So getting that out of there was a nice way to isolate this specific legal language. Both of these had structure and organization of the data that we wanted to reflect the different fields in the cards, different laws, different sections in the laws. And these weren't super consistent. These changed over time. Partially there'd be human error, partially the period in North Carolina where they had fractional laws for some reason, where we have chapter 7 3/4 or something like that, that I have never really figured out why they did that. We had interesting stuff, right, over a long span of time. So we had to kind of work along with these things and try to come up with ways to deal with these problems. So slide. So let's talk through our previous workflow. So when we first started in both these projects, we're talking several years ago, this is before a lot of the LLMs were widely available. We did look at and experiment using some of the earlier transformer stuff, things like BERT that were coming on the scene, but were still relatively new and hard to use. So a lot of our workflow started out with looking at traditional OCR tools. So we had the Tesseract open OCR tool. We had Avi FineReader, we had Adobe. We tried several different tools that were available to see what we could get as the base OCR. Some of the images, like the laws, had been OCR'd originally, but they had been scanned and OCR'd at least a decade earlier. So a lot of that OCR was not in great shape. So we were looking at what kind of, at the time, the state-of-the-art traditional OCR tools could give us. So we had to mix this in, experimenting with these. We had a preference towards open source tools, so Tesseract is an open model. And we mixed this with a lot of other Python stuff, essentially. So we did image analysis to try and figure out, you saw that image before of the banding approach to trying to identify marginalia. We did some other approaches with that, or more computer vision oriented in later iterations. We had to have some sort of custom Python process trying to identify and split out text that was not part of the laws. We used some of these models to try to experiment with with ways to parse out and identify, whether they're stamped, stuff like that. We used a little bit of basic machine learning in this phase as well to try and identify information from an image analysis standpoint to try and identify things that are blank cards. Like the cards project has a lot of, they scan the front and back of every card, a lot of those are blank. Python was also our tool of choice for scripting and automating. We were usually in a space where we had tens of thousands, hundreds of thousands of images to work through. So this really was something where the batch tools that are built into something like Adobe FineReader or Adobe weren't going to work super well. So we tried to work with Python wherever we could to automate. Slide. So if everything goes great, we get our OCR correctly done. We have to move from there. We had an image as a starting point. Now we have a blob of text as a starting point. And we had to parse this into useful data. So this was a lot of regular expressions work. As anybody who's worked with regular expressions knows, that kind of creates its own challenges. It's always often pretty inconsistent. So we were looking for patterns to split those pages of laws into individual chapters, individual sections, extract the numbers, so we could have references we could actually work from. We used regular expressions to try and identify some of the structured things in cards. And a lot of that was very powerful and did we got a lot of good out of it. But the other thing we ended up having to use regular expressions for was often using regular expressions and other pattern recognition stuff, even just looking at the numbers to try and see where there were likely problems. And we end up in this rinse repeat cycle of, hey, we go from chapter 4 to chapter 10. What's going on there? Maybe somebody made a typo and we just didn't get those chapters that year. Sometimes that happened, but we needed people to go verify this stuff. So there was a lot of manual work that's still in the process here. So sometimes that manual work was collecting training sets to try and train a machine learning model to teach a machine learning model how to identify certain things. Sometimes that was us going beforehand and manually collecting metadata about what type of laws were on different pages, because that information was really on a header hundreds of pages before. And a lot of that time was spent on these iterative fixes of the regular expression rules, trying to figure out where it had missed things. We had individual laws that had the whole text and chapters of a town charter or something like that. In chapter 5 might be the town charter that has 100 chapters inside it. How do we deal with that? So we had a lot of manual work in the process. So as we're moving into newer phases with this, as generative AI is coming on the scene, we wanted to experiment with if generative AI could do a bit better on some of these tasks the first time around and reduce some of this repetitive manual work for us. So with that, I'm going to hand off to Rolando.
Thanks, Matt. Yeah, so as we've been exploring using generative AI tools and models for this purpose, there's a couple things or a handful of things we wanted to consider. First is just the general privacy and security issues with using commercial LLM tools, because we know that the data we put in is going to get used to train those models, be commercialized, and sometimes the documents that we're working with, maybe not in these use cases, but in other use cases that have arisen around campus, we're working with documents that contain information about deceased individuals or other potentially PPI information. So approaching this, we were fortunate enough that UNC has a variety of AI initiatives and grants going around campus that we were able to get a grant to set up sort of a access and get money for API usage, and then also space in Azure that keeps all that data within the UNC tenant, similar to the discussion that was had about keeping data within Vanderbilt's data tool. There's also the question of pricing, and when we think about generative AI being expensive, it's not just expensive as in terms of money when it comes to like maybe hosting tools where folks can explore models, and using a lot of these tools has become like just making API calls is relatively cheap. However, where it does get expensive is staff time, both and the amount of learning that we have to do to start be able to use, for example, Python and to make API calls, or to use Azure and set up different platforms, virtual machines, etc. That a lot of those processes were new to our teams and at university libraries overall. So it's really expensive in terms of staff time. Then reproducibility. With generative AI, you can run the same prompt twice, get different responses. And so being able to get reproducible results were something we were cognizant of. And lastly, it's the environmental impact. So, we know using generative tools has more environmental impact than using traditional or traditional models, transformer models, Google Tesseract. So being cognizant that when using these tools, when and how much we're using these tools, because those are going to have an impact on the environmental impact. We also came out with some tips and tricks when exploring these models. First is when creating a sample to see how well generative AI models are going to do for a particular corpus to get a representative sample. Sometimes a certain model will work really well with one kind of document, but with cards, for example, when we didn't have movie catalog cards with forms, it parsed those really well. And when it had a form, it had a hard time, and then other models varied in responses. So having a good representative models of the sort of variation of kinds of documents that you're working with has been really helpful. Second, this kind of goes along with having JSON responses, but what we have for most of these use cases is we have certain core metadata that we do want to extract from these documents, whether that be movie titles or document headers, laws. If it doesn't find any of those core metadata values, then we have it mark that response as flagged for review. So we're really attuned to making sure that we have to review that specific document. And then lastly, we usually have the responses come in JSON as JSON objects, because that makes it really easy to parse and then turn into tabular formatting, or even save those as JSON. So it makes it really easy to make that data usable. So a platform that's been really helpful for us to start exploring how the responses might look like has been LibreChat. So LibreChat's an open source platform that can connect to a variety of different models. In this case, we have it connected to only models within the UNC tenants. So this allows us to work with folks who are a little bit less technical, but are maybe experts and sort of working with historical documents, or when we have our GAs help us with this work. This provides a platform where they can explore and compare results from different documents, and before we start doing larger batch processes. And we have LibreChat hosted on Azure within the UNC tenant, and we have it, restricted to SSO login for folks within our teams who are working on these projects. Again, just to reiterate, it's been really helpful to see, just from an initial glance, if we have just a handful of representative documents, we can quickly see what the response is going to be compared to models at a time, kind of put models head to head and see how they do in terms of getting the right metadata out of the documents we're working with. Some thoughts. Basically, our workflow before required a lot of different steps. We had to maybe train models to classify documents. We had to do either some sort of computer vision or image segmentation processes before we actually ran the OCR. And then we had to run the OCR, and then we had to use regex to extract certain data that we want from that raw OCR text. With this workflow, it kind of condenses all of that into one. Sometimes there might be need for image processing, but right now it's really helped us condense the workflow into something a little bit more simple. This is just another example of some reports we've made, getting that metadata. We've run it on thousands of cards already, and it's been really helpful. So what's next for us? Since we're still in kind of early on in the exploratory phase, we want to explore other transcription models, maybe some LLM-based OCR models, such as Alm OCR, Mistral OCR, Quinn, in addition to potentially using more distillation processes. So where we might get a sample of the cards, have a heavier weight model like GPT-5 or Cloud 4.5, get results that are really good and reliable, and then we can train lighter weight models that have less of an impact, so that have less expense, and explore to see how well those do. Next is evaluating frameworks. So far, a lot of our evaluation has been just manual review of the data that the AI models have produced, but we would like to use something like the inspect framework to essentially use one AI agent to evaluate the results of another AI agent to better improve our workflow for reproducibility, and then also just before we start running it on other hundreds of thousands of documents that we have. Okay. That's the end of our presentation. Thank you so much.
Thank you. Does anyone have any questions? I may have missed this, but were you working with particular programs or faculty on campus for these two projects?
So on the books is a grant. It's a Mellon grant funded project within the university libraries, but we do collaborate with faculty and staff across departments. And then for the movie card catalog we're working with an English professor, Martin Jansen. He brought this catalog to us and asked what we could do with it. So there's a lot of staff interest because you have staff working with archives, and they are sitting on huge amounts of images from archival work and wanting to make that easier to use and maybe easier to share. So yeah, a lot of collections as data work coming up, as you can see.
So do you plan on, I guess, sharing your results of these more formally as far as like workflows, publications, that sort of thing?
Yeah, or on the books, particularly, that's one of the deliverables. And I think Matt, you can speak better with this.
Yeah, I mean, we'll see where we end up. We're at the that's usually kind of the back end of the grant period, and this grant runs through 2027. So so stay tuned. But yeah, putting together some sort of documentation. In the past, we've had GitHub repositories and stuff like that with code bases. But we've also had white papers and things like that that will get put out as part of the process for sure.
That's awesome. I can see maybe a lot of interest from other folks in these types of projects. Awesome. Well, we are at time, so thank you. We will keep the Zoom room open if folks want to keep chatting or in the document, but we will come back in about 15 minutes for the poster session. So thanks, everyone. Awesome. Thank you. And I will let Adam and Eric take it away.
Right. Thank you so much. Good afternoon, everybody. I'm Adam Jansen. I'm the Learning Technologies and Data Librarian here at Coastal Carolina University. And today we'll be presenting on launching a data visualization lab, strategies for maximizing impact at a small to mid-sized university. So we're going to share our experiences of how we launched our data visualization lab this past year, and hopefully you'll learn some tips and tricks from our experience. And I'll go ahead and let my colleague Eric introduce himself as well.
Right. Good afternoon, everyone. I am Eric Resnis, and I am the head of research and scholarship for the libraries.
All right. And just quickly to give you some context about Coastal Carolina, we are a public four-year comprehensive university in Conway, South Carolina. That is in the Myrtle Beach metropolitan area, for those of you who may be familiar. Our most recent Carnegie classification is research colleges and universities, and that I believe was the old R3. And we are now have a stated goal of moving up towards R2, and we're fairly close to that goal. We have a total enrollment of about 11,000 students, and we are primarily focused on undergraduate education, but we do have growing master's and doctoral programs as well.
And so the first thing we set out was to think about, do we need to have a space that can foster data use, data visualization? And this was in conjunction with a new library building that opened up here last fall. And so the first part of that was to take a review of campus to see what facilities even exist that would be capable of data visualization, and there really wasn't much. There is a video wall in the public area of a mixed discipline academic building, but was not used for data visualization. In fact, it's rarely used at all. Most classrooms are primarily one screen, and most use projectors instead of high resolution monitors. And there was one facility that was a bit more geared towards data visualization, but it was designed specifically for our Intel and Security Studies program and was only allowed to be used for those classes. So that told us that there really wasn't anywhere on campus where a broad range of students could use data visualization either as part of a class or part of a project outside of class. And we decided to move forward with having a facility in Thompson Library. After that, the idea was, well, what would be part of this facility from a storage and software standpoint? And so a group conducted a survey of faculty in 2023 to get an idea of how we best could support them with data, either data formats, data storage, data support, and the results from that showed that there was a high interest in the library providing support for data visualization. We did end up using the results of that software to decide on what software would be housed in the facility, and also the storage solution that we would use for data.
And now that we've kind of talked about how we decided to create a space, we had to kind of start planning for implementation. So one of the first things we thought about was audiovisual needs for the space. As Eric mentioned, we had a few spaces around campus that could be used for data visualization, but weren't really. And then that one select space that was really for the intelligence and security studies folks. So we really wanted to make sure we had a space with some flexible audiovisual purposes. We wanted to make sure that we also could incorporate our virtual reality and augmented reality applications as well, because we kind of foresee a need with some of our programs. For example, anthropology and geography have been doing some work in VR. We see some possible extensions into health sciences. So it was very important for us to have a space that could sort of flex for those roles, but with data visualization as kind of a primary concern in mind at this point. We did experience some challenges in setup and implementation. We have in that space, and there will be a shot of it later, about 4 screens. So there are 3 screens on one wall and one on the other. They're all capable of casting. We have an air media system that will cast to each screen, and we can have multiple computers hooked up at the same time. But getting that set up and actually having it run the way we want it to all the time has been a bit of a learning experience. So there were some challenges in setting that up, but we wanted to make sure that when we set it up, it was flexible and capable of being extended to multiple users. And I think at least as of this point now, about a year out, we've gotten most of those kinks worked out. But there was that sort of initial like learning period where we had to figure out what we wanted. We also had to figure out some procedural concerns for how we were going to operate the space. So looking at our service model, were we going to have open hours where people could come in and do visualization work, on an open schedule? Or were we going to go to a reservation only model? Or sort of a by request or on-demand model for classes. And then how are we going to handle software requests? And we'll talk a little bit about software in a moment, but we did kind of decide to have a suite of software installed that was based on what we knew folks were using around campus from that survey data that Eric mentioned. And we wanted to have that pre-installed and ready to go, which we've done. But we know we also needed to set up a request process, which we've done with an online form on our data visualization LibGuide for anybody who might need new software, that we could evaluate whether or not we could purchase that and then place it either on the data visualization PCs or the VR headsets as the need dictates. Lab staffing, right now, it is primarily a space that is staffed and cared for by one librarian, so that's me. But we do occasionally, for certain projects or class assignments, bring in some student workers. We have cross-trained some of our makerspace folks to do some of the data viz and VR stuff. So that is the current model that works for us, but we did have to decide that and kind of base it on our current staff levels and our budget and what we perceived as the initial demand. We also wanted to make sure that we created a set of stock materials we could give out to the liaison librarians, the subject area librarians, and kind of involve them on promoting and talking up the space as they went to department meetings or met with faculty that they knew were doing some data visualization work for their classes. So that's kind of how we approached our beginning discussions of how we were going to set up our service model and how we marketed it, did outreach, and staffed it. And again, really quickly, just thinking about curricular targeting and outreach, I'll talk about that in a little bit more detail. We first kind of underwent a curriculum mapping process where I went through all of the majors that kind of indicated they were doing heavy research and looked at all the departmental schedules and figured out what courses might have a data visualization component. And I reached out to those faculty personally to let them know that this resource was available. I did get some response from that. And then we also sort of isolated some key faculty contacts, department chairs, deans, things like that, where we knew that they would be able to also kind of trickle down some of that support. We did in our survey and in our outreach target those highly productive faculty as well, folks who were doing funded research or were publishing a lot. That was very important to us. And we also did look at those primary research heavy majors. So as you are thinking about setting something up like this, a lab space, I would advise you to look at those majors where you have students who are doing research, where there is a heavy undergraduate research component. So for us, those are majors like intelligence studies, the health sciences, so biology is another one we have interfaced with, digital culture and design, so the sort of digital humanities oriented majors. You might network across a lot of different places where you didn't necessarily expect to find something. Of course, the areas where you do expect to find things are oftentimes those graduate programs where you know you do have students doing some high impact research as well. So I also have key contacts in our PhD in education sciences. We've started doing some outreach to marine science as well. And I know as our health sciences program programs expand, because we're undergoing an expansion there will also be more opportunities to kind of reach those students and get some outreach for the data visualization lab. I also collaborate with the Makerspace. They're right next door to us. And as I mentioned, we do share some staff. So I will do some outreach where I can kind of incorporate things with data visualization in the Makerspace. Just to give you an example of one project that we've done in the past year or so, I have reached out to the geography professor, and we did topographic maps. We used GIS data, and we turned those into SVG graphics that we could put into a G-code format and 3D print. So those students in that geography lab were able to print out topographic maps and use lab exercises to kind of go through the different concepts for landforms and things with that GIS data, which was a very exciting project for us. And just on the right side of that slide, you can see there's a few examples of some of the PR materials or workshops, things that I've kind of sent out. So you can get a sense of what we do and how we try to holistically advertise the Data Viz Lab as a part of our data services in general at university libraries.
So let's talk a bit about installation. And so as Adam mentioned, this is a multifunctional space. It does a lot of things, and that was purposefully designed. Our library system is chronically underspaced, and even with this brand new building, we still don't have as much space as we would like, or compared to our peers, to support student learning and study. So we have made a conscious decision to make sure that all our spaces are as multifunctional as possible. And also we think about, well, in the future, what if this specific use for this space doesn't pan out? What could we do with that space in the future? And so it is used as VR lab and also a small group classroom. In fact, we had middle school students in with us yesterday, and they needed all 3 classrooms, so we used this space as well. It does have 6 workstations. And you see that there are 4 large screens and a 5th outside the room that was intended to show everyone outside what's going on in the room. I had originally asked for a small video wall and was told immediately we didn't have the budget for that. So it was working with our IT services, which this was a very new type of space for them, figuring out how to configure it, and also with the AV vendor that was chosen for this building. And through a lot of iterations, we found that this setup would work best and could best be supported. The system is available of casting to at least 3 different screens simultaneously. The apps that we have installed in this room are mostly apps that we know are highly used by faculty and that have easy support across campus. And so that includes items from the Adobe suite, SPSS and R, but also ArcGIS. Tableau is used by quite a few offices on campus. And then also Deduce for qualitative research analysis, and then also a basic Microsoft Excel. And we found that, many classes that do support visualization, plenty do use Excel to start them off in that journey.
And just a quick word about where we are now, about a year in, and our future development. So, as Eric mentioned, we've learned this space is going to be a flex space for pretty much everything. It is a multi-purpose lab space with, again, the intent that the primary use is going to be those data visualization and VR uses, but we do have classes that pop in. We also had a celebration of scholarship where we used this for a reading and a presentation the other day. So there are a lot of good potential uses for this space. It is right-sized for our institution at the moment in terms of number of PCs, number of screens, things like that. But we wanted to make sure it was set up to be prepared to grow, which we've done. For example, we know VR is probably going to surprise us and be an area of growth. So we've got a storage area ready for things like more headsets, different electronic things that we might need to add as time goes on. But we also want to keep growing those instruction opportunities because, you know, it does typically take a few years for people to kind of get comfortable using a space or find a good use case for a space. So, as I mentioned, our key areas that we're targeting are health sciences, digital culture and design, business analytics and finance are a big area of growth for our institution. So we know we're going to be doing some outreach there. Those graduate research degrees are and will continue to be important. We've done a few specially purposed graduate workshops that have been very helpful. And I want to keep building out those workshops. So we're going to do some more stuff on specific data viz software, data management, AI and data. We have that presentation planned coming up for Love Data Week in February. And we're going to be doing some stuff hopefully on data ethics and privacy because I feel like that's an area where just kind of talking to students informally and in instruction, that's something we need to grow, is our sense of data ethics, privacy, and adhering to those regulations. So that's my plan for kind of rolling things out and continuing in the future. And again, a year out, things are looking pretty good, but they definitely have plenty of room to grow, and that's where we hope we are headed. And just really quickly, I think Eric and I will both share some recommendations for starting the lab. Eric, would you like to talk a little bit about planning for that uncertainty? Because I know that's where you were in the initial stage when you were building this out before Thompson was built. So,
Absolutely. So, I mean, planning for uncertainty we have found was very necessary for us. Something that we have found as we visit other facilities that went big for data walls, we found that they weren't always used. And so it's really thinking about, okay, what if we build it and they don't come? What do we do then? How do we foster and make sure this space is still used and what other needs could reasonably accommodated in this space? This space is a bit more challenging than others because it's not a blank room. It is full of technology, but we feel that right now the suite of services that use this room is the perfect suite, and we still think about, what happens in 10 years and how can we best, what could happen, I have no idea, but what could happen in 10 years and how can we best use that room to foster those future uses.
yeah, absolutely. And I think I will say, at least in planning for uncertainty and thinking about those things, it's important to keep conversations active with the faculty and students who are using the services at this point, just kind of see where they're heading to. That's kind of how I've picked up on the sort of headwinds of data ethics and privacy being a concern, especially in light of Gen AI and all of its uses for data processing. So there are these conversations that kind of arise. Um, and just quickly, I know Eric also was on the financial side of building this as department head as well, but video walls are extremely pricey and they don't work for everybody. So the setup that we have with those smaller presentation televisions arranged in a row that are multicastable ended up being more effective for us. Even still, it's a complex AV setup. It can be pricey. It comes with its quirks. Sometimes we had to reboot the system to get each of the inputs to work the way we want it to. So keep that stuff in mind as you go through this process and think about going with a vendor who has done this before and can support you. That is very important. And be reality focused. What works in your situation right now, but is still going to give you enough wiggle room to grow. And then Eric, anything you'd like to add?
I think Adam touched on the last point quite a bit during the presentation. Think about what existing classes could either are doing elements of this work that could be featured in this space or are really ripe for developing that type of assignment that can be used in this space and using them as an example to others in their department and colleges to get them excited about the space also.
Yeah, absolutely. And that is about it for us. I know we're almost out of time, but thank you so much for attending. And our contact information is here. We encourage anybody to reach out to us if you have more questions. We're always happy to share more about our experience. And thank you so much for attending.
Thank you. I do have a question. I'm going to put mine in the chat while the other presenters get queued up. Thank you.
Perfect. Thank you.
Whenever you're ready.
Oh, okay. Sorry. Hey, everyone. Okay. So this talk is called Hands-on Data, a protocol for creating low-cost interactive data visualization displays. I'm Marla Hertz, the Research Data Management Librarian at the University of Alabama at Birmingham, and I'll turn it over to Sydney to introduce herself.
Hi all, my name is Sydney Orason. I am an assistant professor here at UAB and the freshman composition and student success librarian, and I have partnered with Marla on this project for the last 3 years.
All right. Thanks, Sydney. So, we actually have a very similar idea to Ashley and Aslam at Georgia State. And so by chance, you're going to be hearing a similar presentation today on our interactive data visualization displays. We wanted to provide for you a protocol for how to prepare your own live data capture and encourage you to do so on your campuses. We really think this is just a fun and low stakes way to interact with our library visitors. And it's also a great way to partner with other areas of the library, as you'll see in our talk. So as a background, we've been creating these
Hey, Marla, you're breaking up a little bit.
displays for over 3 years. Yeah, I'll turn off my video. I'm at home, so who knows? And so we'll get about 400 to 600 interactions every year. We also sometimes do these visualizations for other events such as Open Access Week or to accompany a book display. This picture here is a little bit small to see, but what you can see here is one of our displays from Love Data Week. It's an event that happened to coincide with one of our pet therapy days. So you can see here that we made a question based on what dog breed best describes you. And we had to take a picture with one of the therapy dogs and put this up on social media. So Sydney's going to talk a little bit later on the location selection aspect of the project, of the process. And I'm actually going to turn it over to her.
Thank you. Yes, this is like Marla said, this did coincide with our pet therapy that we do every month. I'm sure you all noticed that the most commonly chosen answer for what dog breed are you, most people chose cat, which I just thought was funny. But I want to talk a little bit about why we did these interactive data displays. This programming provided us an easy and kind of low effort, if I'm being honest, way to engage with our library patrons and its different departments and programs. This kind of programming requires no face-to-face interaction between patrons and library employees, which is pretty rare for engagement efforts most of the time. It's some sort of face-to-face interaction. So it gives us insight into who of our patrons or how many of our patrons are willing to interact with library programs just at a base level, those who are in the library very often. This may also encourage them to engage with us in the future. So if they've done a low stakes interaction like this, where pretty much nobody will know that they participated, they may be a little more likely to participate again next time in maybe a person-to-person or group setting for programming that we have. This is also a really great way to cross-promote our library resources and services. So we have two pictures here of different displays that we've done for this program, but I want to draw your attention to the second image here where it says, "What's your most used app?" This was an easy way for us to promote our new app that we had. You'll see that the fifth column there is the UAB Libraries app, which we had just launched. I believe it was that month. So this was an easy way for us to promote that we had an app out, and we had those QR codes beneath the column so that folks could download the app. And it was an easy way to get folks to download the app, introduce it to people. It was a very sneaky marketing opportunity, and this is great for anyway. You know, we also have a 3D printing lab, and we may try to come up with a fun way to cross promote with our 3D printing lab next year. Now I'll turn it back over to Marla to talk about education and data literacy.
Yes, and actually, if you just go back to that other slide for a second, this was also really useful because we have a communications director and she posts stuff all over different places on social media. And so it was really nice for us to see that like the students are using TikTok and Instagram and not so much Twitter/X. And so like it was useful in that way as well.
Great point,
Okay,
Marla.
yeah, next slide. Yeah, so the other main purpose for doing these displays was to get some real data sets that we could use for educational purposes and for dealing with data literacy concepts. So one of the examples I'm showing you here is one where we asked our students to report on how much TV they watch per day at the beginning of the semester during syllabus week, and then at the end of the semester during finals week. And this one was really popular. We actually ran out of the rubber bands before the week let out. And we anticipated that the data was going to look really messy. It just looks like a bunch of crazy colored doodles, right? And so it's hard to get a sense of any trends that are happening in this data. You can sort of get a sense that folks are actually just watching less TV than we anticipated when we made our scale. I think if we did this again, we would expand out the lower range of the scale. I think we overestimated how much TV the students are watching. But anyway, after the events, we take down these displays and I go in and record all the data digitally into spreadsheets, and then I play around with it. I try to make some sense out of it, either aggregating the data, transforming it, things like that. So the second image is showing just a cleaner aggregate version of the data that takes out the individual rubber bands and does line thickness for how much that option was used, and then color coded based on whether their viewing habits went up or down or stayed the same. And so you can kind of see that it's just getting cleaner. And then the next version of its overall for the population increased or decreased or remained stable. Okay, and so basically this allows us to bring in some concepts such as what data transformation does and what information is lost along the way, but at the same time, maybe what levels of understanding are increasing as we transform the data, because in the original messy data, you can't really immediately see that most people's TV watching habits didn't change, that they were stable. But when you actually look at the third graph, it becomes immediately apparent that that's the case for most of the participants. And I'm going to turn it back to Sydney for the next.
All right, so how to actually do this yourself, the implementation. We recommend planning your displays about 2 months in advance. The first time that you do this is going to take a little bit of extra legwork. You need to get all of your materials together. You may be building a display in a way. If you decide to do something like our rubber band display that Marla was just talking about, we actually had a pegboard behind this poster that we then put some little hooks into that students could attach to. So if you do something like that, it may be a little more involved. But after that initial setup, getting all of your ducks in a row, it's really just coming up with your questions and designing and printing out your poster displays. And part of that planning, the first time that you do this type of display, is figuring out what sort of tactile or multimodal elements you'd like to incorporate. We have used, I'm sure you've seen throughout this presentation, we've used a lot of different tactile elements like rubber bands, stickers, thumbtacks, Legos, different things of that nature. I will say that stickers and thumbtacks are the easiest, both financially and logistically, of course, to set up. But the other ones, I think students get very excited about them because they're a little outside the box. Like Marla was saying before, we then promote on social media. We are very lucky that we have a communications specialist here at UAB Libraries who handles our social media accounts. And she posts these displays on Instagram stories for us and as main posts the week of the displays. You don't need to post as much leading up to the displays necessarily to when they're actually out and available to interact with, because it's not a standalone event that patrons are having to plan to attend. They're able to interact with this throughout the week, and if they typically come to the library, then it's likely that they will see it at some point when they're in the library that week. This kind of interaction is also made better by natural engagement, which is how I think we get the most interactions. This is made better by choosing a good location for your displays. We put ours near the busiest, most active and group work-based area in our library. That's definitely not a quiet space. It's an active studying space. And because of that, students are in and out. It's also right before our students will get to our library classrooms where they may be receiving library instruction, and near the writing center that lives in our library. So it's a very high traffic area and we get a lot of natural engagement, which is very helpful. But you could also maybe put this near the front of your library, near one of the main entrances. But there's a lot of different ways that you can kind of choose, and it may inform what kinds of students are interacting with this as well. Like I said, this is right by our writing center, so we may get more students who go to the writing center versus those who may like to immediately head up to the third floor past the entrance. So just depends on where you decide to put your displays for the natural engagement element. And then I'll hand this back over to Marla. Oh, I'm sorry, just kidding. This is me again. We have some tips for success for this presentation or these interactions. Our first one is that make it tactile and interesting for the students to interact with. Like I said before in the previous slide, you have to choose the types of elements that you're going to incorporate. I recommend having all the displays being different types of tactile elements and not reusing the same element twice in one display or in the same display with different questions. So this was one year we had thumbtacks, Legos, vellum paper, and rubber bands, all different types of interactions. So it was a kind of fun and interesting way for students to interact. I also should say that you should use something that you think would be fun to interact with, because the chances are your patrons will find them to be fun as well. Marla?
Yes. Okay. So yeah, a couple more tips from what we've learned over the years. And I wanted to include in here a picture sort of zoomed out of the display so you can see all these elements together as one. And so you can see they're in front of one of the classrooms. All the different tactile elements are presented. And we also have like a poster up at the top advertising that this is for a Love Data Week activity. And so people know that they can actually go over there and interact with it. And also, I think one thing to do is to kind of prime these. Like, we don't put them up just blank. Usually Sydney and I, or we'll have a couple of our coworkers come in and vote. So students are sometimes a little bit worried about coming up and adding to it. Like, oh, is this for me? Am I allowed to do this? And so by having it primed a bit, then they're able to like feel empowered to go for it. And then by the end of the week, it's not an issue and it's just, tons of interactions. Okay, so anyway, for the tips, we want to make sure that we're engaging our patrons with questions that are relevant to them. No one ever wants to feel alienated because the question just doesn't pertain to them. And so we try to pick things that are going to be resonating with the students. And Sydney is our student success librarian, so she has a lot of interactions with our freshmen and first year experience students. So pretty like keyed into what the students are into, but also we'll also lean in on our student workers when we're unsure. And we also want to make sure that the option for the answers are going to resonate well. Low stakes. Again, this is like very unserious. I mean, we want them to be inclusive, but not intrusive. And so basically we want to make sure that this is not the time to be asking deep, like personal or political questions. We don't. And then for the inclusive side, we want to make sure that all the answer options are all the possible options that could be available. And your patrons will let you know if you failed in that area. Recently, we had a data viz where it was accompanying a book display on dogs and cats. So the question was about dogs and cats, and someone who likes birds wrote on a piece of paper about birds and put it next to our display. So I think Ashley showed another examples of that phenomenon yesterday as well. So try to make sure you're being inclusive. Using something like an other category is always helpful. Okay, and then yeah, sharing on social media. Sydney just heard this, but it's a really fun way to get engagement. We got a lot of engagements on those posts, and it also broadens your scope for participants because we've got virtual students, we've got students that don't always come into the library that week, and so we'll have people come into social media and be like, "Ooh, my favorite dinosaur is whatever," and then I'll go downstairs and put a sticker up for them so they can be included. And then yeah, lastly, incorporating this as cross-promotion for other library services or resources or events. Usually it's more successful if it's actually not related to data or data literacy, so that you're seeing that data is being tied to other areas. And so like the library mobile app example, and then the open access example, we wanted to see how much our students were paying for textbooks. And that was a way for us to get in and talk about like open education resources. So yeah, oh, let me see. Yeah, so I think that's about it. I just wanted to say that if you want to use any of these questions at your institution or any of these ideas, like that was the whole point of this presentation, so please feel free to do so. And with that, you can see our very bad joke and ask us any questions.
And of course, feel free to contact us if you have any questions or would like any additional, if you have any additional questions or anything that you'd like to ask, we are both happy to talk about it.
Yeah, there's a couple in the chat if you want to. So have you had any issues with students taking any of your materials when you are not there? We have had students take marbles from our marble pole in front of us.
Oh my gosh. No, from what I have seen, we have not had that instance. But what we have is, we're not typically putting very valuable things out, tacks and stickers and things like that. Legos, I mean, one Lego outside of a set isn't going to do much for you. So we haven't really had this, but as a student success librarian, I do a lot of programming. And one thing that I'm working on right now is a library of things that I know we're going to have loss with. And I have kind of come to the conclusion that loss, a risk of loss is part of library programming. So if you lose a couple of marbles or Lego pieces or thumbtacks, that I kind of build that into the assumption that, well, this is the cost of having fun, interactive displays, and we assume that risk. And then I saw another question. Did we share out our final results afterward? Marla, did we? Do you recall?
So sometimes we do. on social media, and then I also use them in like presentations. So sometimes we're definitely not going to use these for papers or anything serious because it's not like we're getting IRB approval to do this type of data collection, and the methods are questionable. There's definitely some times when I've come in and seen the Legos get stacked up in a certain way, and I'm like, I don't know if those are real votes or someone was just playing with Legos last night. So yeah, everything's with a grain of salt. But yeah, so we share them in classes, sometimes on social media.
All right, I will stop.
I think if you're worried about if stuff's going to walk away, that you really don't care about, I certainly wouldn't put anything out there that I really wanted to get back.
I agree. Definitely nothing, not a full Lego set or a piece from a Lego set that I hold near and dear to my heart. Low stakes items or low cost items are definitely best in that instance.
So having lots of love